Hey guys, welcome to the third session, or the second teaching session of Jetpack Compose camp. So second teaching session, and so we'll be covering topics of Jetpack Compose today. Last time in the first session, we did some topics to understand Kotlin, and we introduced Jetpack Compose to you. So today, I want to discuss a few topics. So I'll just share the PPT. One second. So yeah, uh, so our first topic for the day would be state. We'll cover state today. We'll cover how to make the topic we read rows and columns last time, how to make them scrollable. We'll do lazy rows, lazy column, how to add images, buttons. We'll discuss about constraint layouts and how to adapt to basically different screen sizes because it's not going to be always so Android can be run on TV, it can be run on tablets, can be run on phones. So how to convert your app and make it adaptable to different screen sizes. So yeah, I think I wanted to discuss one more thing with you guys. So for this event, the 1 month we have this camp, you have to make a app before 8th of October, and you have to complete all the tracks for the skill badges you'll get. So I want to let you guys know because some of you had doubts, and yeah. So let's just start with state, and I'll just share my Android Studio. Second. Before state, I'll just give you guys a quick recap of what we did last time because we focused majority of our time on Kotlin, and we just started Jetpack Compose. So yeah, just to refresh your mind. So basically, what I told you guys was कि if we were to start a fresh app, just go to your file, make a new project, and choose a empty compose activity. You'll be able to start your project. And so the topics we discussed in the first session were firstly rows and columns. So uh, so if you want to display or text in your app, we just use a simple function text and just enter the string inside of it, what you want to show. So if I were to run this set of lines, what we did last time, just load, yeah. So what we did in this was we displayed the set of text we had hard coded text in a column. So if we were to just simply type for text, it will all be in the top left section and you won't be able to read anything. So for that we used columns, and inside of columns we use something called modifiers. So modifiers are basically helping you have attributes of a particular uh, thing. So you can have attributes of a column which would be common to everything that is inside that column. So if you will notice, the we have set the background of the column as yellow, and every text also has the background set as yellow. Or we have set the horizontal alignment to be in the center. So basically hello should be in the, so if you see this line should be in the center horizontally. So every text will have the same effect. And with vertical arrangement, I have said even you can change these alignments and arrangement. There are a lot of options that you can check out. So similar to columns, we did rows, and what rows did. was the same thing, just yeah. So what we did in this case was align our text in a row. So place it horizontally, and yeah, and just I think the modifiers are almost same. So yeah, should be able to understand that. And yeah, one more. So this example was just to show you how many more attributes you can add to a particular column. And one more thing about modifiers, you could also add it to a text. So we just printed simple text over here. Hello and world are just simple text. What if you want to make the text bold? What if you want to have a specific font to it or have a border to it? There are a lot of modifiers to it, and there is a bunch of lists you can see in the documentation of what all you can basically add to a particular element. So, and one more element we discussed about was spacer. So, spacer is a blank space that can be provided, and we just gave it a height with 100 dp. So, dp is a unit for you to give space in basically the dimension for Android. DP is used for text, basically elements, and SP is used for fonts, so text sizes. So yeah, discuss that. And I think the last major topic we discussed last time was styling text. So like more attributes towards text, and we created a box for it. So box is also help us in layout. Uh, it's a part of it's a kind of a layout for you to add elements to it. So what we did was we did one more thing, how to change if it's a string hello daddy, it's one string, and what if you want to add some attributes to hello and other attributes to daddy. So that we did using build annotated string. We added, so to hello we added these properties, and to daddy we applied these attributes. So yeah, this was I think till last session, and now we'll cover state. So basically, what state is, what all we did over here was very static. Uh, we hard coded everything. We told the compiler that we need this text, the text should be this, the color should be this, the font should be this. We hard coded everything, but obviously in your apps not everything would be static, and we want to make it dynamic. Say, let's say you click a box and you want certain text to be shown, or you want a color to be changed. So for that, I have an example for you guys. Color box. This is a composable function we made. So what all I did in the above cases, above examples, was just write the code directly. I didn't make functions. I wrote the code directly. But obviously, if you're making a project, try to make composable functions and just call them in the main class. So yeah, this is the color box function that I've created. So what I've did is I have taken a modifier as a parameter, and this parameter has a default value as an empty modifier. So if nothing is given, just give a empty modifier to it. That's what it says. So this is the part that would be new to you guys, that is remember and mutable state of. So what we have created a variable color val, and I'll just show you the output. So you will be, what this basically does is this code. So it just fills the screen with yellow, and once I click it, it's going to change its color, the whole screen. So this is a box, and I've just set the color, initial color, as yellow. So what state does, so initial, we have created a variable of type state, which is mutable, because we want to change the color of yellow. And remember basically does is, it helps us the variable to not get overwritten in the first time when we compile it. And so what we did was, we in the modifier of the box, we added a attribute that was clickable. that this box is clickable. And what clickable has, it gives you a lambda function, and we can basically, what we did was inside the lambda function, we changed the this variable's value to a random color. Now, how this random was created was using a random library in Kotlin, and so basically color take. So this is like the RGB color coding. So any random float will give you the combination of RGB, and this is thus displaying random colors. And yeah, so what we did was we made a particular box that was inside our composable function a dynamic box. We changed its basically attributes um, inside the composable function. But what if you wanna basically change the attributes of something that is outside your composable function? So that's why I've created this other example, color box, same name, just more difference. I'll show you what this does and we'll break it down. Yeah. So instead of one box, we have two boxes of same basically weight. So basically, they are of same dimension, uh, filled 50-50%. So what this does is the first box is set the color to red, and once you click it, it's going to change the color of the second box. Cool. Uh, so what we did was we created a column because we wanted two boxes, and this time if you see, we didn't create the mutable function inside that function because it was out of we want the result to be out of the scope. We basically, what we want is this box, the second box that we created, get a random value from the first box, because the first box will initialize a random value. Once it is clicked, we want the second box to get a random color to be filled, and we want this dynamically. We Yeah, so what we did is we didn't declare this mutable function inside of this color box. What we did is we just if you see what all parameters we have, let's see, we have a modifier, and in case we don't give a modifier, it gives you an empty modifier's default value. And the second thing is a variable that is a function which will take a color and returns you nothing. So basically, we did was we made a box of background color red and made it clickable. What clickable did, we can give a lambda function to it, a simple function. So this update function, what it does is it gives us a random color. And now, yeah, random color. And what we did was we made this mutable object in the main scope, and once and yeah, so once this was initialized in the main scope, and once this was clicked, this color dot value background would be changed by the first box, the color that we get. And yeah, so and I told you guys, so it basically is a default return value in Kotlin. So like we did the example of, if there is a list, there is a function called, you usually in a programming language you do for I in range length of an array, just get the, yeah, or in Python for I in array, just print out I. So similarly, this I is replaced by, there's a default value in Kotlin called it. So if we were to run a for loop for array dot for each, you can get the value of it. So yeah, it will be, it is iterated and you'll get the value of it. So yeah, this was for states. So basically, two examples. One where we had to change the state inside a composable function, and the second where we had to get the value which was going to change in the main scope and work accordingly. Uh, so yeah. So the other thing we I'm gonna discuss now is we did columns. So and what if there are many items in your column? We just have two right now. What if you have 69? What if you have 420? What if you have triple eight? What if you have 420? So can we have any number? So what we did is we made a simple column, and now you'll understand we're going to use state a lot. So this is a default state for compose. Compose has made us so this remembers scroll state is by Jetpack Compose. So to basically initialize the initial value of the scroll, like where should the scroll start from. So initially, so that we have to make it remember. Key remember, not get overridden. Just start the scroll from the upper half, the first initial position. So yeah, what I did was I made a column. I ran a simple for loop. So in Kotlin, if you don't remember from the first session, for in range function, basically what this does is this part 1269. It does is it creates a list, and I is going to iterate to that list. So it's kind of like in range 1269 do this. So yeah, and I'm going to create a text with many parameters. So text will have a text to display or what we want to display, and this dollar sign I, if you don't remember, is what if you want to add a variable inside of a string. So we use dollar sign and then the name of the variable, and we gave a font size. And so yeah, so you have noticed that we had given the dimension for a particular element as dp, and for text sizes, for text we give the dimension as sp, sp. So yeah, we did so yeah, we added a alignment to the text. The text would be in center, and we gave a modifier to it. What modifier did is added the text to be fully fill at max. And what padding is, I'll show you the output and then tell you what padding is. Yeah, so we made a it's gonna scroll till 6. Yeah, uh, yeah, it's gonna start from 1. And yeah, so vertical padding is basically this distance, what's gonna be uh, for the text. Sorry, vertical padding would be distance between the number 1 and the hello daddy number 2. So this distance, so once this gets printed, I want a 24 dp space vertically. So it's gonna give a 24 sp space, and then gonna print the next element. So if so, in your emulator, just use the left click of your button of your mouse eye and just scroll down. You'll be able to scroll easily. Uh, so now there is another method to build this, that is lazy columns. So what lazy column does is it's the same thing, but with one difference that you won't realize, I think, when I run this. So notice what we did is we didn't have to declare a mutable state for this, because lazy column default it does that on its own. It gives its mutable state so that it starts from the beginning. And what we do is we didn't even run a for loop. So it has a function called items. So in items we have to give the number of items we want. And similar thing we did, I displayed the text with similar attributes. So if I just run this, uh, yeah, except for the text, I change the text. So if you do this, it's gonna go till I've put the range as 420. So it's gonna show me it's not inclusive, or it's gonna start from zero. Let's just see. Yeah, it's starting from zero, so it's inclusive. We have done 420. It's basically the count. So yeah. Uh, so the difference that I've told you is one, we don't have to declare a mutable state, and secondly, you don't have to basically use a for loop. There's a inbuilt function for that. And the third thing that I'll is that if I make a scrollable column, it's gonna render all of this in one go. Once it's in run, once it's initialized, it's gonna render everything in one go. But what this does is it's gonna render only when I scroll down to that particular section. It's not gonna scroll make what's the last 419. So when I run this, 419 will not exist as when I scroll down, and when I reach that section, then it's gonna render. So this is basically more efficient and make your app more smooth. So when you have like large number of items, that's when you use lazy column. I can so do 1,000. So it's gonna go up till 1,000. Yeah, see how smooth it is. I've done 1,000. Yeah, and with column, if I do 1,000 ka range, it's not gonna be as smooth because it's gonna render everything in one go. And but the difference between this is it's gonna only render this section. 8, 7, 8, 7, 9, 8, 7, 6. It's gonna render when I scroll down to that particular section. We'll just 420, and yeah, this is lazy column. Oh, one more thing in lazy column that I want to show you is so yeah. What if so this the text we had for the range. What if you have a list and you want to display each element of that list to this column wise? So horizontally, you want to print each element of a list. So if you don't remember from the last session, we can make a list in Kotlin using this syntax list of and just then comma separated elements. So lazy column has a function called items index, and what this will take is a list, and when you run it, this function in the body, you can basically get the index and the element of the list. So I have getting the index in the variable index, and I'm getting the each value of the list in a variable called string. And I've added the text, that is to add the particular element of a list into string, and same attributes have been used. So alignments and the adding everything is same. So yeah, I'd run that already. Sorry. So yeah, see, it's gonna return you the element and the index it will have, the corresponding index. So and yes. So yeah, then we can discuss about so similar to lazy column is lazy row. I'll just quickly run it for you guys. So what this will do, we did it column wise, so this will do row wise. This row will become uh, basically scrollable, and so same differences. So lazy row had, we don't have to make any mutable function, everything. So same for that, is just we did this for row and we did that for column. And similarly, we can also do this index function. We can get the elements of list and display them in a row. So to show you, because this was a short text, I added a little string to show you it's scrollable. And yeah, so same stuff. Now we discuss this. Next up, we can discuss how to add images to our Jetpack Compose. Um, yeah, must have created. Yeah. So I've created a composable function for this. So I've just created a function called image, and the image function in Jetpack Compose takes painter as a parameter, which basically helps you locate where the file is present. And if you notice on my left, there is a complete directory of my app right now. So if you notice, there is a rest folder, and inside of that rest folder would be a drawable folder. And inside the drawable folder, you will add your images that you want to use in your apps. So just you can just copy paste an image, drag and drop whatever you want to do, and yeah, or you can do is add new vector, asset, whatever image. So yeah, file anything from your local. So I've added a local image named lol.png, and I want to render it to my page. So the first thing was to use Painter. Painter basically helps you locate where the file is present, and we use Painter resource function, which will basically take the ID. ID will take the paths. This is drawable folder, and inside drawable folder is the name of the file. And there is we have given content description what this image is, and we just have given a modifier which just gives us a padding, so distance from the upper end of the app. So how many dp do you want to set? Or I'll just call this function, I will call it image. So yeah, this was the image uh, that you had. Padding, if I could show you. Yeah, padding, yeah, I can easily show you now. Therefore, if I do 100, so you see the distance between the upper screen and this. This is padding. I can do it 10, 9, 420, whatever. So 420, yeah. So this was not fit to 420 when it went out of the screen. Let's keep it as cool. Yeah, this was the image. So yeah, you will need to upload your images in rest folder, and you can easily call this function. And yeah, I'll just comment this out. And yeah, so the other thing I want to discuss is a button. So you can create a simple button in Kotlin. I've created a composable function for that. It's named simple button, and it's gonna take a button function which will take on click. So it's gonna take it can take a text that you want to display on the button, and the other is the a function of what will happen if I click the button. So I'll just run this one too. Image, there is a button. Just run that. So yeah, it's displayed me a button, and of course you can add the all the modifiers and everything. I've added to simple button too, like padding, or you want to add some more uh, attributes. You can do that. So it's clickable automatically. You don't have to make it clickable, and yeah. So this was button, and yeah, whatever you want to do, yeah, on click. Uh, the lambda function is there. Whatever function you want to call after this button is click, you can add it over here. And so yeah, Now, okay. So we have done the kind of layouts we have done in till now can be rows, columns. So layout basically tells you how each element is going to be placed. So what row did was place everything vertically separated like a row, meaning, and column. Sorry, a column did vertically and a row did it horizontally. Place your elements. What this other kind of layout that we can define, that is constrained layout. What constrained layout does is, I'll just show you a simple code. That is, I have created a column and I have just added two simple buttons. So what we did was use. What if I wanna place the second simple button with respect to the first uh, simple button or anything else? Basically, I want to I want to set the layout according to uh, a reference element. It could be a button, it could be text, or it could be this. So there's also a term called parent. So what parent is this screen. What if I want this button to be separated from the parent body with 50 dp? That's what we did padding. So but padding is from vertical, so this distance, uh, this axis. But what if you don't want to make it column wise? What you know is how this second button would be placed according to the first button. The reference point for the position of the second button depends upon the first button. In column, what we did was we just wrote कि these buttons have to be placed on like in a stack. But we didn't basically mention how it's gonna be placed. So you can use alignment and arrangement, but to set or basically give a definite value. Or there is this another uh, element that we haven't discussed. That is, you can define a line, gradient line, and I can say like the position of this line is in center, and I want this button's position to be 50 dp above that line. So that's what basically constrained layout does. And what I did here is I have created two boxes. And so for constrained layout, we have to do three things. We have to create a variable called constraints, and inside of that it will take a constraint set function, constraint set, and we'll add whatever uh, basically we'll add elements whatever we want to display and give them IDs, a reference name to be precise. And what we'll do is we'll create then constraints. So what I've did is I've created a green box and a red box, and here I can do what basically I can do is yeah. So with this, I'm saying key from top, link the green box to the parent. What's the parent's top? It should be the top of the green box. So at here, this is the parent's top, and the green box should be at top too. And start is this distance. So just parent ka start. So basically, the position of the simple button would be the green box's location, and the second constraint is a red box. So what red box will have its position would be parent ka top, but it will start linked to the green box. When the green box ends, the red box is gonna start. That's the thing, and you can give the height and width, and you can also give the dimension respect to the constraints. So imagine this. simple button is here, and there is also a button over here, and I want the width to be filled completely after this button's width is filled. So this distance I want to cover. So for that we use fill to constraints. Whatever space is left by the constraints, we have added this green button, this green box, and it's gonna take up 100 dp of it, which would be like this much space. So whatever space is left over here, it should be given the width to that. And yeah, similarly, you can give height, you can give value, you can give percentage, how much percentage you want to get filled. So once you have created the position, and see, we have created a box ka reference. We haven't created a box variable. We have created, if for a particular id, we have created an id called green box, and that id will have this layout details. I can set this ID to a text also. We in this case have used a box, and inside modifiers, what I've done is set the layout by ID, and ID I've given as green box. This is the constraint layout. So yeah, what we basically did is define how a particular ID will be arranged in the screen, and we can now give that id to a box, to a text, or anything, and we can give that id via layout id function, and it's going to take the id, layout id. And like column, we made a constraint layout, use the constraint layout keyword, and yeah, so yeah, it's gonna take a constraint set as a parameter that we created above, constraint set, and yeah, modifier is optional that added to basically fill it to the full size. So yeah, so yeah, I think the last topic for the day is gonna be how to adapt your apps to different sizes. So there could be a compact phone, there could be so we are not gonna look at the code today, because problem with that is we have to, I'll tell you guys what the method is to create so basically the our approach how to create adaptive sizes is basically what we do is we create custom classes, and that's the reason I didn't want to start the code today, because we haven't oh, sorry. One more thing that I wanted to add with constraint layout is this. I'll forget it. So constraint layout is not basically added in the dependencies, or basically you can call a library. It's not defaultly added. We have to add a dependency. Dependency can be called as external libraries, so external resources we want to use in our app. So uh, how do we do that is using is in the Gradle scripts folder. So inside the Gradle scripts folder, uh, yeah, sorry. So inside the Gradle scripts folder, there would be a build.gradle, the second one, module one, not the project one, and you'll see this folder. And if you scroll down, there would be a dependency section, and I've added that. Yeah, so you guys won't have this for default. I'll send the this text, if you this set of line, and I'll add it to the PPT, and to the, if you want the WhatsApp group, I'll add it. But yeah, so you'll have to add this line in the build Gradle, and for you to run constraint layout. And I think if you, yeah, even if you guys are blindly just to try your copy pasting these codes and trying to run on your Android Studio, you might get some errors that would be most probably is you haven't imported a particular library, and that can be easily resolved in Android Studio. So I guess I can show you an example. I haven't I have imported this ui.unit.dp. So I'll just comment this out, and wherever I have used dp, I'll show you. I might have used dp over here. Yeah. So see, it's gonna throw me an error. It's gonna say dp cannot be used. You haven't imported this. So just hover over it. There's also keyboard shortcut Alt Shift Enter. Just you can easily click it. Just hover over the arrow line, and it's gonna import it for you. So it import for us, and it's gonna work perfectly fine. So yeah, so yeah, where were we? So yeah, the last thing about constraint layout I just want to add, you just have to add the external dependency in the build Gradle, and yeah, you'll once you add this line, you'll get an option to sync now with the Gradle. If guess I can show you that too. I'll just control V. I just added changes. Yeah, so I've changed. So I'll just sync now, and I've removed the dependency, so it shouldn't work. The constraint layout code. Just add it again. I can sync it now. So if just remember to sync your Gradle folder to add the dependency in your code in your project. And yeah, so last thing that I want to discuss with you guys was yeah how to adapt to different sizes. So we were going to discuss how we're going to approach this problem. So what we do is we create our custom classes, and we get the window information. So I'm using Pixel 3a, this phone. There could be Pixel 5a, but what we generally do is we categorize into three ranges. One is compact, the other could be medium size or extra large, whatever you want to call it. But with DPIs, we'll set three ranges. One would be for phones, one would be for tablets, or one would be for TVs and etc. Whatever. So we'll have a specific DP amount, and if it crosses that, we'll identify it's not a phone, it's not a tablet. So what we do is we create a custom class. We try to get the information of the window that is available on the app. What is the size of the screen? And once we figure that out, we create multiple layouts. We create multiple composable functions. So imagine my whatever code we have written till now is inside three composable functions. That is set one composable function for phones, one for tablet, and one for uh, basically TVs and extra large stuff. So, and we just gonna use simple if else. So if the we'll once we create a class and get the window size information, if this size is in this range, compose this function. If the size is this, compose this function. Obviously you can also do inside the, you don't have to create a composable function, but compulsory you can add it in the if else block too. But obviously your whole code would not fit, if it's a medium size project, it won't fit it too. I mean, it would fit, but obviously it will be very complicated for you to understand. So just create, what I would suggest is create three functions for three layouts. How the layout is going to change according to the screen size. And yeah, so what will so yeah, that's why the reason I didn't want to start this topic was that we have to understand different types of classes in this Kotlin object oriented programming. We're gonna start tomorrow. So yeah, sorry. Yes, sorry guys. So yeah, what we were, yeah. So we have to like declare enum classes. We have to have sealed class. There are different types of classes in Kotlin, and we couldn't get to discuss those in the first session. But yeah, to understand that topic, we'll so tomorrow we'll do a little bit of Kotlin too. What classes are, I know different types of classes. Tomorrow. We'll also cover navigation, and since we would be able to do navigation, so we can have a splash screen. We can discuss what splash screen is, and yeah. So I think tomorrow's session we'll cover like 80 to 90% of the first 4 units, and I'll just cross check the syllabus and we'll try to cover as much as we can of the first 4 units that you have to do tomorrow. And yeah, and the fourth session would be, I've scheduled it for 23rd, but the thing is I also have my midsems coming up, so I'll let you guys know about the 23rd session. Oh, yeah, about the 23rd session I'll let you guys know, but I think, yeah, tomorrow will have session. We'll cover, yeah, most of the topics. So yeah, I guess, yeah. So hope you guys understand the whatever we have done. If you guys have doubts, just try to contact me over email, then my phone number. So yeah, we'll have the session tomorrow, Saturday at 7:30 p.m. And yeah, yeah. So if there aren't any more doubts, we can wind up the session, and we'll pick up tomorrow from, yeah, the how to adapt to different UI. Yeah. So thank you guys for attending the session, and hope to see you guys tomorrow.